Something very important and useful when you're developing an IoT application is to simulate devices, but not just sending random data. Troy Hopwood is here from the Azure IoT Solutions team, and he's going to demo us the latest and greatest features that we have in the device simulation service to do exactly that. Simulate devices, but advanced one with advanced type of data and behaviors. Hi everyone, this is Olivier, your guest on the IoT show. Today we're talking about device simulation, and I have Troy Hopwood with me. Hi Troy, how are you?
Hello, I'm doing great. How about yourself?
I'm awesome, I'm great.
Awesome.
I'm having lots of fun here. We had like tons of really great episodes today, so the bar is super high. Don't want to put any pressure.
Yeah, no worries. Yeah, I'm a long-time viewer, first-time presenter, so this is good times.
So you're working in the the Azure IoT Solutions team, and you're looking after the device simulation, right? Exactly. Which is kind of awkward for an IoT group to simulate devices when you think about it. No devices, no toys. However, you have a fantastic and totally necessary technology that you're creating here, right?
Exactly. Yeah, we're kind of the oddball in the IoT space where we're not doing real IoT, but we're simulating the world. Our job here is to make it easier for developers to build on top of the Azure IoT platform.
Yeah. And when we're talking about IoT, we're talking about billions of devices, right? So you need to test your applications where you do development with 1, 2, 10, 100, but then how do you make sure that once your product is in the wild, is successful and basically starts spreading, how do you test ahead of time that your application will be resilient, will be actually working the way you were expecting it, right? So that's one of the
exactly. Yeah. Scale testing is an important piece, and we've all heard stories of Christmas Day, everyone turns on their device, and suddenly some service tips over. And so being able to simulate at the expected scale is an important piece of simulation.
Got it.
Whether it's you expect 5 devices, which some services that could be a large number, depending on how the solution's built, to thousands to millions.
Yeah. So I hear there's tons of new features, tons of features your team has been working super hard at adding. So far we had like simple simulators that were able to send random pieces of telemetry. But when you want to simulate an actual real-life situation, you need to put some templates and patterns onto that simulated data to actually push your system to the boundaries and really test it, right?
Right.
So what are these new features that you guys have been building?
Yeah, so we've really focused on 3 different aspects of the evolution of simulation and testing within your IoT solution. You want something quick and easy. I just want data to flow, and I don't really care what that data is. Okay. I just want to see something flow, figure out how all this works, to where I have some very basic scenarios where I want to just randomize some telemetry data. I want my temperature anywhere from 0 to 100 degrees, simple things like that. But then when you get to real devices, you care about the actual device behavior. So something like, imagine you're trying to simulate a parked car on a hot day.
Yeah.
It's 90 degrees outside. Well, it's going to get to 100 and some degrees inside, right? And being able to have those kinds of relationships where you have an exterior temperature sensor, interior temperature sensor, and model behaviors between those. As the temperature goes up, so does the inside by some factor.
Makes sense. Makes sense. Okay. And you came with demos, right?
I did.
Awesome. So let's go through what you have. Let's see the demos, and let's have people then being excited and use it, right?
All right. Cool. So out of the box, we kind of give you this get started guide to walk you through those 3 scenarios that I talked about. And so you have the sample simulation or custom devices, which is that just random telemetry or some simple telemetry, and then advanced.
Okay.
So if I wanted to just get started quickly, I can start a sample simulation. And out of the box, we ship some sample simulations. They're simulated simulations, if you will.
Okay.
So here you can see I have 10 devices. Can scroll down and see there are 10 trucks. And I can just go up here, click Start Simulation, and it's going to start simulating these 10 trucks. These are some sample devices that we've delivered and sample simulation. So this truck is moving around. It has some temperature data as well. And quickly you can see that data flowing into IoT Hub. But I could also come into simulations and start a new simulation. And this is kind of that medium scenario.
Okay.
So I'll just even call this my intermediate
Scenario.
demo. Give it a description if you want.
Okay.
And you can specify how long you want it to run. So you can say, I want it to run for exactly 1 hour, 12 minutes.
Okay.
Or you can say run indefinitely, which means run it until I actually stop it.
Okay.
And I can add device models to it. Just because I did a truck before, I'm going to go ahead and choose a truck here.
Quick question while you're doing that.
Yep.
So you were saying you can run the simulation for a limited amount of time. So because you're simulating against services that are running on your subscription, actually one of the reasons not to go too long in time is because you're going to actually stimulate your IoT hub in the back end, and it's going to cost you money, right?
Yeah, certainly if you're sending too much telemetry, you could end up hitting throttles on your hub. So certainly if you're using an S1 hub, for example, and you say, I want 20,000 devices to send messages every 10 seconds, you're going to tip that over pretty quickly. But at the same time, those are legitimate scenarios that you want to test as well.
Totally, yeah. As we're saying, device simulation is also about testing the scale of your app and what it can ingest in terms of data from devices, right?
Yeah.
But I think it's very useful to have end the demo or the simulation after some time, so that way you don't forget.
Yeah, that is a completely viable scenario if you want to make sure that it does stop. You don't want to be there at 3 a.m. to click stop when your test is complete. You can schedule it.
Okay.
So here I can see a list of these are all the sample device models that we ship with. And if I don't like any of these, which obviously the odds of these matching your actual devices are probably slim.
Not everyone uses trucks in their IoT apps.
Not everyone, yeah.
Not everyone.
Everyone else uses chillers, I think, is clearly.
It's clearly, that's for sure. But you have like good models that are actually there for.
So you can create your own device models. So
nice.
Come over here to device models, and now I can say, all right, instead of a chiller, I've got a lawnmower. If I can learn how to type lawnmower, and you can give it a description, version. So I can have multiple versions of my lawnmower. This is lawnmower 1.0, just so I can keep track of it. And then what do I care about? Well, I've got blade speed. That's pretty important. And I want random behavior of 0 to 5,000 RPM. And maybe my lawnmower, I mow the lawn more when it's warm out, so I want to collect that data. So I'm going to add a temperature sensor.
Okay, you have a smart lawnmower.
I don't think we can have an IoT demo without temperature anyway.
So it's the baseline. Temperature, humidity.
So in addition to random, I can choose increment and decrement.
Okay, so you can simulate a situation where something is getting hotter, for example.
So no one's going to consider mowing their lawn if it's sub 50 degrees, and no one's going to do it if it's over 100. And let's say it's Fahrenheit. So I now have this device, which obviously the best device. I don't know why it's not out there in the market. But then
you can create your own collection of these devices.
And now I can create simulations that use my lawnmower as an example. But what gets really interesting is if I go back into my try and create a new device model, there's this advanced tab. And this is where I can get into that car scenario I was talking about, where you want to script behaviors where based on one sensor, another sensor behaves differently. You want something more than increment, random, and decrement. And so I can upload a JSON file and a JavaScript file. So the JSON file is a device description file. It defines really the device's capabilities. So it says, all right, I have these sensors, I have these properties, I support these methods, that sort of thing. And then the JavaScript determines how to actually populate those sensors. So you have temperature. Well, how do you want to vary that temperature, that sort of thing. So if I jump over here to VS Code, I can see in the JavaScript device description file, I have some initial state. So within the simulation, we have every device has its own state. So you can remember what it was the previous time it sent telemetry. This allows your temperature to react based on the previous temperature, things like that.
Makes sense.
So initially, I'm going to say, all right, velocity. Well, we're doing a drone here. So initial velocity is 0. That makes sense. It's not going to be moving out of the gates.
Yep, yep.
And it's going to measure millimeters per second is the speed. Acceleration's not moving, and it's going to give it just a default starting location.
Okay.
And altitude as well,
altitude,
0.
Because it's a drone. It flies.
Yeah.
Yep.
And then how frequently do you want it to send data? In this case, it's going to send data every 1 second.
Okay.
And then you define your behavior file. Yeah. So this script here.
So I see 1 second now. Can you go down to the millisecond or not yet?
Not yet.
Okay.
And only through the advanced device, this scenario, can you go down to 1 second. Through the UI, it's currently 10 seconds.
Okay. Okay. Which in most of IoT scenarios anyways is plenty enough, because you don't send data every 100 milliseconds to the cloud. It doesn't make sense.
You alluded to this problem earlier. People discover pretty quickly that if you're sending telemetry every second, every sub-second, it gets expensive very quickly.
Totally.
So realistically, there are very few scenarios where you need data that quickly. But if you do, then there are solutions to manage that in a more reliable way, such as packaging together your telemetry and sending it less frequently.
As bulk. Yeah, makes sense.
So the key here is this file right here.
Okay.
This is the behavior JavaScript file. So it tells the model, hey, I need to go look at this file to figure out how to manage my device.
Okay.
And every second when this device runs, it will execute that script.
Oh, okay.
There's some other things here, properties. In this case, it's a drone. I have a firmware, and I have a model number.
Okay.
I can add tags. So Contoso owns this particular thing. And then I can define the telemetry. So I can actually define a JSON template here. So I can control what that schema is.
Okay.
And then I can also specify what the name for that schema and the version for the schema.
Okay. And here we find the different names that we had in the state, right, of that simulated device.
Yeah. So these are actually, usually a subset of the state. This is the actual properties that you want to send in the message payload.
Got it. Okay.
So it's defining that you want a double, you want text, that sort of thing for the actual payload.
Okay.
And then a feature that we're working on right now, so this is a sneak peek at something we're adding, is support for cloud-to-device methods.
Okay.
So you can define those methods here, and again, call out another script for that.
So you can go all the way to simulating telemetry going up, but you start being able actually to simulate the reaction of a device to a command from the cloud.
Exactly.
Okay.
So in this case, it would be a command to recall my drone. So I've been flying it around. I don't really know where I am in space anymore. And the panic button, just call it back.
Super important.
And it'll figure out how to get back to me.
Awesome.
And so we're kind of simulating that scenario.
Okay.
So if I jump over to the script, here there's it's anything you can really do in JavaScript you can do here. There's exceptions where you can't call out external APIs and things like that. But really whatever you can imagine scripting you can do. So you can define a bunch of constants that are used here. Nothing
Is it
really
fair to
exciting
consider that
there.
as a serverless function, where basically it's going to be called every time the model needs to run, and it's going to apply whatever math or whatever function you have in net, right?
Yep, similar concepts, So really what we do, every time it runs, there's a main function, and this is what we call. So first thing we're doing here is we're restoring the state. So it's, is this the first time we're running it, or is there a previous state? So that state object we were talking about before, I can now reference that and say, I want to load that, so I now have, where my drone lives and its elevation is all based on the previous state.
Yep, makes sense.
And in this case, my drone moves, so I want to set acceleration. And everything we do here is based on this state object. So we're updating the state as we go. So
makes sense.
The current acceleration is, and then I have this vary method that takes in some input parameters, min, max, and the variation, and then it will return back, here's the actual speed.
Makes sense.
So that's acceleration, and then velocity is the actual speed.
Okay. Makes sense.
And then you have coordinates, latitude and longitude. So this moves the device, moves the drone around in space. and altitude moves it up and down.
Okay.
And so altogether, this ultimately controls how that drone moves through space
Yep.
and does a lot more than you could do through the basic random increment, decrement
Makes
kind
sense.
of scenarios.
Makes sense. I would assume you can call APIs as well from here, right? So your JavaScript file here could leverage another library that eventually would do more reach treatment on that state, right? So you can imagine more like math type of algorithms that would actually implement some smarts on how that data evolves, right?
Yeah, that's currently not supported.
Okay.
But yeah, that's direction we're
Okay.
looking is how can we provide either some canned methods to do some important things
Okay.
like follow roads, for example. Can we do things that make that easier for you?
Yeah.
But yeah, right now you can't call out to anything external.
Okay.
We've got a couple.
You would have like bring the code into that. You can. That's going to be a big JavaScript file.
Yes.
But that's yeah. Okay. Got it.
Yeah, and I've experimented around trying to make the most ridiculous JavaScript file I could, and just to see what happens. And it does work, but yeah, from a coding cleanliness perspective, it can get a little ridiculous.
But we're going to get there because that makes sense. I mean, it's an iterative process, and we have the engine is able to do that now, and we're going to enrich that, right?
Yeah. It was definitely fun playing with a 10,000 line JavaScript file.
I like your definition of fun.
So once I've done this, so I've defined my JSON and I've defined my JavaScript. So now I can come back into device simulation in the advanced experience where we dropped out, and I can browse, and I can see here I've got my drone, I've got the behavior file, and I do have this method that we talked about. I didn't go into the details of. I do need to include this just because my JSON actually has a pointer to it, and so the validation would fail.
Got it.
We're not going to actually be able to leverage it just yet in this release.
Okay.
So let me load those. You can see everything passed, which is awesome. So I'm going to go ahead and save that.
And if you made a syntax error or something like that, you're going to have a nasty sign that says, hey, I cannot use that thing because...
So yeah, if I didn't include my JSON file, or missed a file, or it's an invalid JavaScript, things like that, it's some basic validation. We're obviously not going to know, hey, you didn't call this method, or you have a divide by zero error, things like that. But at least basic validation to ensure you're not uploading a picture of your cat and calling it JavaScript, which I know you would do. So you can see I have my drone here. So let me go back to simulations. I'm going to create a new sim. And this is my drone demo.
Okay.
And I just keep skipping description, so I'll be consistent. And I'm going to choose the drone. How many of these do I want? Well, let's say we want...
Do you have a max number today?
Today it is 20,000. If you need to go higher than that, give me a call on my personal number. No,
People will do that. You realize it.
We have in private preview support for up to 1 million.
That becomes interesting.
And that is something we're planning to release soon. And we're not
already,
planning to stop there
playing
either.
with like 20,000 drones already is a big number.
Just for fun, I'm not going to go to 20,000. I'll just choose 300 drones. That's probably
300
enough.
flying drones is already something.
And a neat thing we added is the fact that we can clean up these devices when we're done. When you're doing 20,000 or 1 million devices, if you leave those in your IoT hub when you're done, it can be quite messy, and ultimately you could run out of capacity within your hub.
Makes sense. And I see just above, we didn't mention that, but you can actually like create the solution actually will create a hub for you to test everything, or you can actually input the connection string of your own IoT hub already existing in your solution. Right?
Yes, that's a good point. So optionally, you can deploy a hub. We'll deploy an S2 hub. But if you already have a hub existing and you want to use that, or for whatever reason you want to use the free hub or an S1, you can do that. You can also upgrade the S2 to an S3 if you wanted. So you could upgrade it to a 10-unit S3, which you'll need when you're getting to millions of devices.
Makes sense.
It's just simple. Click that and paste in your connection string for a different hub if you want. So I'm going to go ahead and start that. And you can see at 300.
Okay.
And just like with the built-in devices, I can see the actual device model here.
Okay. Yeah, let's see.
And at this point, it will set up. I can see statistics for my hub. This is real-time statistics for the hub. It'll go back an hour. And you can see I had some stuff running earlier.
Okay.
Everything stopped, so now it's flatlined.
Okay.
And then as this sets up, we will provision the devices. So 300 devices should provision fairly quickly. If I chose 20,000, it would be a longer demo.
Yeah, makes sense.
And so you'll see the devices connect, and then we update twin properties just to indicate it's a simulated device.
Okay.
And then we start sending telemetry for each of those devices. So the telemetry will slowly ramp up as each device connects.
Okay. And we'll see that appearing. In a nutshell, now we have this more richer functionality for the device simulation. People can find it where today?
So if you want to deploy it, you go to Azure IoT Solutions.com.
Okay.
And you can see device simulation and some other solutions here.
Okay, that's
so
one of them.
If you go into device simulation, click Try Now,
Okay.
and you deploy it into your subscription. There's no cost for device simulation itself.
Okay.
But it does consume Azure resources. So you will be paying for the IoT Hub if you choose to deploy that.
Okay.
There's storage, there's a VM, things like that. So
Okay.
there
But
are
if
resources.
in a situation where you deploy device simulation and you point to your existing IoT hub, we're not charging for that simulation, like compute, basically, right?
We're not charging. There's no charge for an additional hub in that case.
Got it.
But yeah, you still have the compute resources.
We still have
you
the compute. Got it. Okay.
The storage.
Okay, makes sense. Makes
database.
sense. Okay. Awesome, Troy. That's great. So AzureIoTSolutions.com, go try it out. Have fun with it. Provide feedback as well, right? Because we're
most
evolving
definitely.
product. And feedback can be sent over directly to his phone number because he said he would share it. Thanks a lot, Troy. See you soon. Thanks, guys. Don't forget to subscribe.